All right, welcome back, everybody. I've got a new kind of a setup. Hopefully, you can see better. Today, I will try to go kind of quickly. I'll try to go over the two things that I'm going to ask you about in the big quiz, the kind of midtermy kind of a thing that's coming up. We're supposed to do last week, but I kind of wasn't quite thinking we were quite ready yet. So I'm going to just go over the main things from propositional logic today. Things that I've already covered, but I'm going to do it a little bit quicker, just assuming that you already kind of know the stuff. Right? And so there's two main things that I'm probably going to ask you about in this midterm when it comes to propositional logic. One is do a truth table to define one of these connectives, right? Remember, there's four connectives. Propositional logic is like a game with four pieces, just like chess has like six different type of pieces. Here, there's four. These are the main four. So to know what these are and how they function, when we actually do logic, you should know how each of them works with a truth table, right? So I'll go over that for all four of them, just to remind you, and then I will look at some arguments. So I'll put up some arguments. That'll be the other thing. I'll ask you, can you evaluate this argument for validity using a truth table, right? So we've done that before, but those are the two main things. Define one of the four connectives, or all four of them, using a truth table, which we'll do first right now, and then check to see if a deductive argument is valid or invalid, right? And we'll look at different arguments, and then you can see how to do this, right? How to use the truth table to determine validity, which we already did last time, so hopefully you kind of still remember, right? We'll end up putting an argument across right here, and then we'll look at all four possible worlds to see if there's any corner of logical space, right? To see if there's in any of these rows, do we find a pattern where all the premises are true and the conclusion is false? If we do, right, I call that a gremlin. We're trying to spot the gremlin. If we find a gremlin, the argument is invalid. If we don't find a gremlin, the argument is valid, right? That's how you play the game. I'll remind you again once we get to it. Right now, let us do the four connectives, right? The four logical operators. Technically, three of them are connectives because they connect two different statements, right? That's why for three of these, we can use both P and Q. For nots, we just use one of them. Right? So let me erase this, and I'll just go through each of them. We'll start with and. Just as a reminder, these letters here, we call them variables, and they stand for statements, right? True or false statements, like Socrates is wise, or it is hot, right? Things like that. Right? So when I say P and Q, I'm just sort of saying two statements, right? I'm saying it is hot, and it is sunny. Socrates is wise, and Socrates is mortal. Right? So we could write a whole big complex sentence like that instead of writing it all out in English. Socrates is, almost said Socrates is hot. No, it is hot and it is sunny, or Socrates is mortal, and Socrates is wise, right? Any one of those, I could write it out like this: P and Q, right? So this just says both of these statements are true, whatever statements these end up representing, right? Once we start doing logic, we stop caring about what they actually mean. We're looking at the form of it, right? The logical form, as it's called. And then we just sort of take this and what does this look like if somebody says this in this possible world, right? Because these are all different possible worlds, right? P and Q could both be true. That's one possibility, right? So a possibility, we just call it a possible world. It just sounds more exciting that way, right? But it's possible. We don't know what P and Q stand for. Maybe they're both true, right? Maybe, we don't know. Maybe P is true and Q is false. Or maybe P is false and Q is true. Maybe they're both false. We don't know, but these are all the possibilities, right? So if I say P and Q are true, right? That's what this statement right here means. When you say P and Q, you're essentially saying P and Q are both true, right? Well, if you're in world one, good. And good luck, because that's the world where P and Q are both true, right? So in this possible world here, P and Q is true. And now we know Let me just make sure I am actually recording. Yes, I am. And I'm not muted. Okay, good. Now we go to the second possibility where P is true and Q is false. Well, this statement says they're both true, right? So we know that in any of these other possible worlds, if either P or Q is false, then the whole thing is false. So we should just know when you define disconnected, it's just going to look like this. True in the first world, false in all the other ones. Right? So this is how you define the AND operator, the conjunction, right? You should know the technical terms too, not as important, but remember this is the left conjunct, this is the right conjunct. So the rule for conjunction for an AND statement is it's only true if both conjuncts are true, which is the case in world 1, but not in any of the other ones. And when I ask you to define a an operator, or when I ask you to define any of these operators, and you'll have to do this on a piece of paper, and you'll have to work your way to the answer. You're not going to necessarily submit your work when you do the quiz, but you will have to do this, right? And you just do it like this every time. Anytime we have two statements, whether it's with a connective or if it's in an argument, whenever we have two statements, there's just those four possibilities, and you'll always set it up the same way, right? You have the first variable and the second, and under the first, you always go T, T, F, F. That's just like you're right, T, T, F, F. And then underneath Q, you always go T, F, T, F, right? Alternating one after the other. And that just gives us, by laying it out like that, that gives us each of those possibilities, right? We don't know if P and Q are true or not. They could both be true, and they could both be false, or one or the other is false. So now let's go to the disjunction, or operator. So I might ask you, to know the definition of the or operator. I might have to ask you the questions indirectly, right? I might just ask you, in what situation is this statement false, right? You'd have to know, well, it'd be in this one right here, right? That's the rule for the disjunction, because this is an exclusive an inclusive or, right? That means P or Q, this statement is going to be true as long as at least one of the disjuncts is true. And it's also going to be true if they're both true. Right? So you're basically saying one or the other or both is true. Right? So the only situation where that's going to be false is when they're both false, right? So we can put an F down here, and in all the other situations, we can put true, because in all the other situations, at least one of them is true. Okay, so this is what it looks like when you define the disjunction operator. For the conjunction, we have true, false, false, false. For this one, we have true, 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 false. Right? They all look a little bit differently. They all function slightly differently. And you need to know that for when we do the actual arguments. Right? You need to know how each of those works in order to do that. Now we have the if-then. Hopefully everyone remembers the rule for conditionals, right? It's called a conditional. This first part is called the antecedent. The second part is called the consequent. Right? Remember, for conjunction, we just say left conjunct, right conjunct. For disjunction, we just say left disjunct, right disjunct. Here we say antecedent, consequent. The rule for conditionals is it's only false in the situation where the antecedent is true and the consequent is false, right? And that's in world 2, right? That's the only place that it's going to be false. Otherwise, it's just true by default. Because remember, an if-then statement is like a rule, and a rule is automatically being followed as long as it's not being broken. It's kind of weird, but that's just how it is, right? As long as the rule is not being broken, it doesn't matter what you're doing, right? You're not breaking the rule, so the rule is not being broken, so that's fine, right? The only world where this rule is broken, because this rule says whenever P is true, Q is to be true. Well, P is true in this world, but Q is not. So in that world, it's going to be false. If you utter this sentence in this world, you will be called a liar, right? Because in this world, the truth of T does not guarantee the truth of Q, right? and they're true in all the other ones because the rule is not being broken. In none of these other worlds do we get a true antecedent and a false consequent. And that's the only thing that would disprove this statement. So here the rule is a conditional is only false when the antecedent is true and the consequent is false. In other words, it's only false in the world 2, it's true in all the other worlds. Now, we have our last one, negation. Negations don't connect to 2 different variables, right? So we only need to work with 1 variable. And I guess to make it consistent, we'll just use Q because then we can still use the true and the false. So we have 1 variable, and that variable can either be true or false. We put a negation in front of it. Then underneath of the negation, we just have the opposite truth value. So if Q is true, then not Q is false. If Q is false, then not Q is true. And in a way, the negation just says this is false, right? If you put a negation in front of Q, you're just saying Q is false. That's sort of what you're saying. Right, so if you're right, if Q is false, then you're right to say Q is false. If Q is true, then you're wrong to say Q is false. So then your statement will be false. If that's weird, again, just remember, this just flips the truth value. Whatever the truth value is of Q, not Q will be the opposite of that. Okay? So that's all 4 of the pieces, so you should know this as well as I did right now. It doesn't take that much. It all really makes pretty good sense if you just kind of slow down, realize there's not that much to learn. Right? There's the first part, truth tables for the operators, and you need to know those in order to do the next part, which is the real point, evaluating arguments for validity, right? And just to remind you, hopefully this definition is etched into your brain. An argument is valid when the truth of the premises guarantees the truth of the conclusion, right? That is to say, it's not possible for a valid argument to have true premises and a false conclusion. It's just not logically possible, right? And we don't even have to know what the statements stand for. We can just know this by looking at all the logical possibilities that there are, right? Then we can figure out if an argument has that possible world or not, right? If it has the world where the premises are true and the conclusion's false, right? There's a gremlin that tells us that the argument is not valid. So that's what we're doing. And this only works for arguments that have 2 variables. Probably tomorrow, I'm going to look at arguments with more than 2 variables, and then we have to change our technique a little bit. And in fact, you can already use the technique here, but it's better to kind of understand what you're doing by seeing it all laid out first. Okay? So let's just look at an argument. I'm going to just stick to really simple arguments first, just so they're familiar, right? And you can sort of, if you already know, especially that they are valid or invalid. For example, I'm not going to tell you this time if it's valid or not, but you should know, because this is one of the argument formats. This is one of the argument formats that you're supposed to learn, right? That's one of the other things you're supposed to know how to do, is recognize certain basic argument formats that repeats. And some of them are valid, so that's good to know, and some of them are invalid, and that's good to know. So everybody hopefully remembers that these 3 dots here, that's not some big new complicated thing you have to learn. That just means therefore, right? And the comma just separates the premises. So we have one premise, if P then Q. We have another premise, Q, and then the conclusion, P, right? So you should sort of see it as separated. Here's all the premises, and here's the conclusion. Whatever's after the 3 dots is the conclusion, right? And so what we want to figure out is, since there's only 2 variables, we know there's just 4 worlds where we could take this argument, and then we just want to see, will this reveal the possibility of true premise, false conclusion? Is that logically possible? That's what we're looking for. And that pattern, what does that pattern look like? That would look like T, T, F. right? If this premise was true and this premise is true, but the conclusion is false, then the argument is invalid. Because again, that's the definition of validity, is in a valid argument, it's logically impossible for the conclusion to be false when the premises are true. And we're literally looking at all the logical possibilities. And so we could make it appear, right? If this argument is invalid, then we will make this gremlin appear, right? Gremlin has a, you imagine true as green and false as red, right? Kind of a common association. You could think of the gremlin as like this snake animal that has a green body and a red head, right? A tail of green, head of red. That is our gremlin. That's what we're spotting. And in a invalid argument, we will find a gremlin. In a valid arguments are gremlin proof, right? So that will not show up. So let's see. All we need to do is go through and figure out what the truth values are for each of the premises and the conclusion in each of these worlds. So in this world, where P and Q are both true, we know right away that the truth value of Q is true. And we also know right away that the truth value of P is true. Because we're visiting this world right now, right? Remember that that's what we're doing? We're going for a spin across logical space. There's 4 quadrants in logical space. We visit each of them, right? And there's 4 worlds. So we are in the first world, the world where P and Q are both true. Then I like to just circle them when I have the truth value of a premise or a conclusion figured out. So these are figured out. This one is not quite yet, right? Because here we have a complex statement with P and Q. Now we know we're in this world where P and Q are both true, so then you just have to go back to what we just did with the conditional truth table, right? What does the conditional truth table look like again? Well, it's only false in this world, right? So in the first, just look at your truth value table, your truth table for this. It looks like this, right? That's what it looks like. So we know if we're in world 1 that this thing will be true. So this is the pattern that we expose here in world 1. We have a T and a T. Tension is mounting, right? This is a tail of green right here, but it's also a head of green, right? So that's fine. That's not a gremlin. Right? So world 1 does not expose a gremlin. There's no problem yet. So let's move on to world 2. Right? So we can do the same thing for these ones. That's easy. P is true in that world. Q is false. Right, so I'll just circle those. Then we just need to figure out what is the truth value of this in this world. Well, this is the world where the antecedent is true and the consequent is false. We know from the definition of a conditional that that's going to be false right there. Boom. So no gremlin there. Okay. Now I'm telling you, very often, I know this from gremlin hunting, right? I've been across logical space many times, and I know from experience that gremlins often like to hang out in world 3. Okay, so let's see what world 3 reveals. In world 3, P is false. Okay. An F there. And Q is true. Well, according to the definition of a conditional, conditional is only false in this world when the antecedent is true and the consequent is false. If the antecedent of a conditional is false and the consequent is true, the whole statement is true. And boom, gremlin detected, right? TTF. This should be exciting, right? This is what we're looking for. It's always kind of more fun to figure out that an argument is invalid because you get to spot the gremlin, right? You spotted the beast. All the premises are true and the conclusion is false. Then that means this argument format, regardless of what P and Q stand for, this argument format is not going to cut it because it does not guarantee the truth of the conclusion, right? Because here, if we happen to be in world 1, because remember, We don't know which world we're in because we don't know what P and Q stand for. So if we're in world one, then we can have true premises and a true conclusion, but we don't know. The truth of the premises could also give us a false conclusion. So remember, a valid argument format, it's like when you load up the premises, you stick the premises inside of the logic machine, and it always comes out with a true conclusion. This argument format, you could feed it true premises, and sometimes a true conclusion comes out, sometimes a false one comes out. So you cannot trust this form of reasoning. It does not reliably lead you to the truth. And that's the whole point of listening to valid deductive arguments, right? It's because they preserve the truth. You know that if your beginning information is true, then the inference that you make is also going to be true. With this format, we get no such guarantee. So this is invalid, right? For the gremlin, invalid. And hopefully you remember this is called affirming. The second premise affirms the consequent. Affirming the consequent is an invalid argument form that you learned about, a couple weeks ago. So let's be done with that one. I'll do one more simple one, and then I'll add a negation in there. About actually, you know what? If we do it like this, we can already do negation. Okay, so that says P or Q, not P, therefore Q. For the big quiz, you should already, just like the previous one, you should know that that wasn't affirming the consequent. You should know that already, okay? For any of those 6 familiar argument formats, you need to just be able to spot them on sight. So this is one. You should know what this is called, and you should know whether this is valid or invalid, okay? So I guess I'll tell you, but you should already know, right? This is a disjunctive syllogism. Disjunctive syllogism. I'm not going to tell you yet whether it's valid or invalid. We'll find that out. So, and soon we're going to learn the short method, so we're not going to have to do all these truth tables as much. There's a lot of work. It does, even though it sounds exciting to hunt for gremlins in logical space, it can also get a little bit tedious, right? So we'll learn the short method soon. But let's do this for this one. We go to each of the worlds to see what happens to the premises and the conclusion, right? So we're trying to figure out the truth value of this premise, P or Q, this premise, not P, and the conclusion, Q. Right? So in world one, where Q is true, well, I can sort of circle this. Okay. I might need to close that window because that doggy's going crazy. This is distracting me. P in that world is true. So I could put a little T here just to remind myself, but look, the premise is not P, right? The premise is not P, right? So we have not yet figured out the truth value of this premise, but we know that P is true in this world. And if P is true, then remember the negation sign just flips the truth value. So if P is true, then not P is going to be false. And then we can think about our rule for the disjunction, truth table. Remember that a disjunction is very easy for it to be true. At least one of the disjuncts needs to be true, and it's also fine if they're both true, but at least one of them has to be true, right? And that's true in world one, right? Both P and Q are true. Well, with the inclusive or, that means this whole disjunction is going to be true. So we get a T, an F, and a T, no gremlin. In world two, we have P being true and Q being false. So Q is false here. P is still true, so it'll be the same as this one. So not P is false in that world because P is true, just like here. I don't need to write another T here, you get it. And then we can think about our rule for the disjunction. As long as one of them is true, then the whole thing is true, right? Then the disjunction is true. Okay, good. One of them is true, so the disjunction is true. We get a T, an F, and an F. No gremlin. Okay, let's move on. Here, P is false and Q is true. So Q is just Q, so that one's the easiest one to do. That rhymes. Did not mean to do that at all. P is false in this world, but that means not P is going to be true. It's just whatever you need to keep yourself on track, right? So you can just use whatever technique you want. Just make sure you keep things on track, and always remember the truth value of the simple statements goes right underneath the truth value underneath the simple statements, like right here, and the truth values of the complex statements goes underneath the operator, right? So because it's underneath the V, that means this truth value applies to this whole statement. And because this is underneath this, it means this truth value applies to not the whole second premise. Okay, so we're in that world. We're in world 3. It's getting a little messy. Again, we're over here. P or Q, is that true? If P is false and Q is true, yep, as long as at least one side is true, which it is, then this gets true. Okay, still no gremlin, right? We do see that if you feed it all true premises, so far we do get true conclusion back, right? Which is what you want in a valid argument format. But sometimes the valid argument format will not have the TTT pattern, right? Because the whole thing is kind of like a conditional. It's if you load it up with true premises, do you get a true conclusion every single time, no matter what world you're in? Sometimes you can't load it up with true premises, right? That happens sometimes. But in this case, we put in true premises, we get a true conclusion. Let's look at the fourth possibility. P and Q are both false. So Q is false here. P is false, which means that not P is true. And then this is the one, right, where the disjunction is false. That's the rule for a disjunction. A disjunction is only false if both sides are false. Otherwise, it's true, right? So it's true in all these worlds, but false here. Still no gremlin. We've looked at all the possible worlds. So no matter what P and Q, no matter what simple statement you put in there, right? You know that if the premises are true, the conclusion's got to be true, because that's just logically the only way it can be. It can be no other way, right? So no matter what true or false statement you stick into these P's and the Q's, if the premises of that argument are true, then you are guaranteed to get a true conclusion, right? That's the power of deductive reasoning, and you get that guarantee. Okay. Let me do something a little bit tricky. Just to Now, I don't do a lot of this kind of stuff. You could have a slightly more complicated statement. Like you could say, if P, then two things are true, right? Then this and this is true. Sometimes it's like that, right? If it's sunny, then I want to put on sunscreen and go run outside. So sometimes a conditional says, if this one thing is true, then these two other things are true. Right? So if you want to say that, if you want to say, if P, then Q and R, right? Then you put a little bracket right there. Q and R. Just like that. Then I could say P, therefore, you know what, I'm going to make it. I'm still going to write that. I need a little more space. If P, then Q and R equals P, therefore not R. I think this will be the last one that we do, also because I'm running out of this. This will be the last one, and this is slightly more complicated. So these brackets just mean that this is my conditional. This is my conditional, and this is my consequent right here, right? So it's much more complex, but it's still, this is one big premise. I have a comma here, so this is all one big premise. This, not P, is a premise, and not R is a premise. The conclusion. So the conditional here has P as the antecedent, and Q and R as the consequent. But the same rule is still going to apply, right? The conditional is going to be true in most of the world, except for the world where P is true and this whole conditional is false. Sorry, this whole conjunction is false. Because that the conjunction is the consequent here, right? This is a conjunction, and it functions as the consequent in this conditional. I hope everyone's following now. That's quite a lot of fancy words, but hopefully you get what I'm saying by this point. And so we'll do the same thing. We just go through and we identify the truth value, right? Well, P. Oh, no. We need, sorry, I added another variable. We need to do the short method for this one. Right? I forgot. I just added a third variable. And that would mean that I have to add another variable here. And remember, that means I have to double how many. So for this, we have to do the short method. And I was going to do that tomorrow. So I'm going to have one other final one. Not that one. That one does not work for our purposes today. Let me just do one more. Let's do another one with a conditional in it. Let's do it slightly simple. Not P, therefore not Q. This is also one of the argument forms that you should know, right? Just by looking at this for the quiz, you should know what is this, right? Hopefully you know that it is denying the antecedent, right? The second premise here says not P. That's denying the antecedent of the conditional, right? So, go through the worlds, right? P and Q are both true in these worlds. But if Q is true, that means not Q is false. Everyone sees what I'm doing there, right? If Q is true, because it's true in this world, then this conclusion, which is not Q, is going to be false. P is true, same sort of thing. That means not P will be false. And we know from our definition, right, of the conditional that that's going to be true in this world. Right? When the antecedent and the consequent are both true, this whole conditional will be true. No gremlin. World 2, where P is true and Q is false. So Q is false in that world, which means not Q is true. P is true in this world, and that means that not P is false again, just like in world 1. And we know from our definition of conditionals, world 2, that's the one world where the conditional is false, right? It's breaking the rules. The conditional says whenever P is true, Q has to be true. But in world 1, somebody's breaking the rules. P is true there and Q is false. So the rule has been broken. Nowhere else does this rule get broken, right? So it's going to be true here, it's going to be true here, it's going to be true here. Just not in world 2. No gremlin. That's just fine. World 3, right? Like I said, this is often where they hide. Let's see if this is where the gremlin is. Okay? So Q is true in this world, so that means the not Q is false. Because again, all I'm doing is looking at the truth value of Q in world 3, right? That's the row I'm trying to figure out. You know, it's a little messy, but I'm in row 3. I can see that in that world Q is true, and that means not Q is false. And in this world, P is false, right? P is false, which means the premise over here is not P. That's going to be true. But again, P is false in this world. not P is true, because the negation just flips the truth value. And this one, well, we know, right, from the rule that if P then Q conditionals are very easy for them to be true. They're always true unless the rule has been broken, which is in World 2. But in here, it is also true, and we find a gremlin, which you should connect to the fact that you should know, right, that denying the antecedent is not valid. It's an invalid argument form that people often use, but it's mistaken because we get the pattern. We get the gremlin pattern, right? We get the body of green, tail of green, head of red, right? Dorky thing to say, but it just makes me visualize, right, that there's this monster we're looking for, the monster of being illogical, right? For this argument format, it's possible for the premises to be true and the conclusion to be false, right? So it's not reliable, right? It's, if we imagine this format, this denying the antecedent format, as a box that you feed truth into, it sometimes will pop out a truth, sometimes it'll pop out a falsehood. And so it's just not reliable. And so you should not use this argument format because it's invalid, shown by the fact that there's a gremlin, right? This shows that it's logically possible for the premises to be true and the conclusion to be false. So gremlin invalid, done, right? Okay. I'm wondering if I should do any more because of what I'm going to put on the, I can't just use these argument formats. So I might just show you something less familiar. I'll do one more here. Maybe something slightly weirder. Something like that. I don't even know if this is going to be valid or not. But this says P and not Q. Right? You could put brackets around it. You don't really need to for negations because it's pretty obvious what this is saying. Right? This is a conjunction of saying this is, right, P, yes, and not Q. So maybe something like it's sunny and it's not windy. Right? Maybe that's what you're trying to say. P and not Q. Right? So the rule for conjunction is still the same. We need both sides to be true. Right? It's just that one of the conjuncts is not Q instead of a simple variable like we're often used to. Right? This just says P or Q, and then this says P. I think this is going to be valid. Kind of want it to not be valid, but I'm pretty sure this is going to be valid. Yeah, yes. But let's quickly do it, just so you get the idea. I just want to make sure you're prepared for these kind of curveballs. And if I only show you the familiar argument formats, you might not be ready. So I might show you something like this, and I want you to be ready for this as well. Right? So I might say, tell me, right, if this argument is valid or invalid. And then that's all you'll be able to tell me on the midterm, right? You'll just have to say valid or invalid, sort of true or false. But you'll figure this out on your own on a piece of paper by using this method. So you'll go through, make sure you get the right answer, and look at each of the possible worlds to see if there's a gremlin, right? So in this world, P is true and Q is true. They're both true. Okay, so that makes this one easy. P is true. P is true and Q is true. So that means the or statement. I'm going to go a little faster now, okay? So you just consult your truth tables for the P and Q, P or Q. P or Q in world 1, where they're both true, that statement itself will be true. P and not Q, might have to think about this for a second, right? P is true, okay. Q is also true, but that means not Q is false, right? So that means that the whole statement is false because this conjunct is false. If it had just said Q, it'd be fine, right? Then P would be true, Q would be true, and the whole statement would be true. But because it's not Q, is this the right conjunct? That means the right conjunct is false. And when you have a left conjunct being true and the right conjunct being false. When you have any conjunct being false, the whole statement is false. So I'm going to put an F underneath that. Sort of erase that. Put an F under that because this whole statement is false in this world. Right? Sure, P is true. The left conjunct is true, but because Q is true, that means the right conjunct, not Q, is false. P is true, Q is false, so P true. P or Q in this world, because P is true, that means the whole statement is true, because at least one side is true. Here, it's going to be the same issue. No, it won't, because this time, P is true, right? And Q is false, but that means not Q is true. So we get both of the conjuncts being true, right? So P is true and not Q is true. So that means it's true here. Down to this one, P is false here. P or Q, this statement, this premise right here, that's going to be true because Q is true, right? Because the rule is as long as either P is true or Q is true, then the whole statement is true. Okay, so that one. This world P is false, and not Q is also false. That means the whole statement is going to be false in this world. And both conjuncts are false this time. Because P is false, and Q is true. That means not Q is false. Both are false. And the whole thing is false. Okay, final one. P is false here. P or Q is false this time because P is false and Q is false, and that's the only time that the whole statement is false, right? This junction is easy to be true. That's why it's true here, true here, true here. Just false in the fourth world. And then finally this one. This is P is false. Well, then we already know the whole thing is false, right? So you don't even need to do the other one. Of course, it happens to be Q is false. That means not Q is true, but P is false, right? So we get false on one side, true on the other side. That means the whole thing is false. No gremlin in sight, right? We can actually see the good pattern. If we have true premises, then we definitely get a true conclusion, right? It's just not possible for these premises to be true and for the conclusion to be false. If that was possible, our truth table would show it because this shows all the logical possibilities. Okay, so hopefully that's enough for you now to know how to do both things. The most easy one is defining each of the truth tables, right? Using the truth table method. Slightly more complicated is figuring out validity by using a truth table. Right? And then probably tomorrow I'll show you how to do the shortcut method. Because notice, we're looking at all these different worlds where some of them we know there's not going to be a gremlin, right? So we know, for example, we laid out both of these two worlds, right? World 1 and World 2. But we already know there's no gremlin, because what does a gremlin look like? True, true, false, right? So if we're in a world where P is true, yeah, we don't really need to check out that world, right? It's like we're fully exploring each of the quadrants of logical space when we can just take a quick look, right? If this is one of the corners where the conclusion is true, then we already know we're not going to find a gremlin there, right? So that's part of the rationale behind the short method that we'll be learning soon, right? It's that we can sort of just focus on which of the worlds is going to be relevant. And one of the things we know is we only really need to look at the world where the conclusion is false. Right? And then we can work our way backwards to see, well, if the conclusion is false, could we make all the premises true? Right? Is there a possible world where all the premises are true? Right? So we sort of work our way backwards when we do the short method. Make the conclusion false, try to see if you can make the premises true. Right? I'll show you how to do that in the next session. Okay, so hopefully this works because I'm doing this on a different thing. I'm recording this all directly to CapCut. The quality is so much better. You can see my scraggly beard too. But at least hopefully you can see this a little bit better. Okay, let's pause it now. I'll see y'all soon.